Okay, in IM2 today we're going to talk about graphing a factored quadratic in intercept form. So when they say intercept form, they're talking about factored form, and they want you to understand that you can graph straight from this form, but you have to understand a few things. So the first thing you're going to look at is the A. Is it positive, meaning a happy face graph, or is it negative, meaning a sad face graph? Then you look at your two x-intercepts. These are your factors, and your x-intercept would depend upon the sign there. So if it actually was, say for example, x minus 3, we know that the intercept would be 3. So this, when you look at these two, I am looking at two positive solutions. Okay? And then if I had one that looked like this, so x plus p, I would know that that was a negative solution. So they don't go into quite as much detail as this, but I think it's really important that you quickly notice the differences. This is the standard form, so they're both minuses, but if you see a plus in your solutions, x plus 7, that means that your solution would be in your factor, then your solution would be negative 7. So watch for that when we go over these next few problems. Okay, so there's what we can tell. Okay, this is a problem from your journal, and I thought it was really good in that we could see things in a little better light. But they just give you a very basic problem. They're pretty much telling you, is it a positive graph or is it a negative graph, with the only change being the sign in front of there. So we're going to start basic like they did, but then we're going to get more complex as we go. So for this one, I can see that I have two positive solutions. If I plug positive solutions into this formula up here, then I'm still going to get the x minus p and x minus q. P and q just represent the factors that go in there. And then I can see it's a happy graph, so I'm just going to write f of x equals. Okay? Over here I have two positive solutions again, but this time I have a negative graph. So this one, the basic form, is just going to be negative x minus p, x minus q. Okay, now we're going to start adding a little bit of stuff. So on this one, the thing I want you to notice is that one of our graphs, one of our solutions, I mean, is 0. We still have a happy graph, and we have another positive number. So now when I put it in, instead of just putting the f of x equals positive negative, I'm going to remind you that there might be a number out there, and that will come in handy as we keep going, because we have to be able to remember that we have GCFs that come out. And then the next one would be x minus 0 and then x minus q. And so this one could be simplified to a and just x and then q minus x minus q. So we don't need to write this whole thing here like that, just to know the basic form. So I want you to know that when you see it like this, then you still want to look, there's one of your solutions here, which is 0. Okay, over here we have another solution that's 0. Again, this is a positive, and then we have a negative solution. So I'm going to go f of x equals positive a. I'm just going to put an x there because I see that I have one that equals 0. And this time I'm going to put the number in, 1, 2, 3, x minus negative 3. And what do you see happens here? So this should be ax and x plus 3. So if I was going to write it in the standard form, it would be the x plus q. But it actually would just still be x minus q, but q is less than 0. So I just want you to be able to recognize that this would give you 1 is a 0 and 1 is negative. Okay? All right, over here we have a sad graph. One of our solutions is 0 and the other one is negative. So we're going to go the f of x equals negative a, and we have a plain 0, so just put it like that, and then x minus negative q. So you could write it like that, or you could write it x plus q. Okay? So I'm just trying to make this more complex than they gave it because they left it very simplistic, and I think it's easier for you to see in this form than in all of them having the same answer pretty much. Okay, over here we have a sad face graph. We have one solution equals 0, and the other one is positive this time. So we're going to say the f of x equals negative ax, and then we're going to go x minus q, and we're done. Remember that this qx is x minus p, or x minus p is 0, so that's why I only write the x. Okay? All right, on these last two, this is a positive. We have one positive and one negative solution. So I'm going to go the f of x equals a, it's going to be a positive a, and then we have x, does it matter which one? No, it doesn't matter the order. So x minus p, x plus q. And that's just telling us we have one positive and one negative solution. Okay, same thing over here, except we have a negative graph. We have one negative, one positive. So let's say I go left to right. Doesn't matter which way you go. So I have a negative a, and this time I'm going to go x plus p and x minus q. Again, it doesn't matter which order you put your parentheses. Okay, so I just wanted to show you that in a little bit more complex terms so that you could understand exactly what you're seeing when you see factored form. All right, so this is telling you that as they said before, the intercepts are p and q, and we know that the axis of symmetry is halfway between them. So here they found the average of the x-intercepts, okay? And then you found the axis of symmetry. So that's how you find the axis of symmetry when graphing in intercept form. Okay, so this next problem is from your book, and it gives you an actual equation, and it says identify the x-intercepts. So first thing I'm going to say is it's a sad face graph. My x-intercepts are -1 and 5. I got those by solving each of these for 0. And then they want you to use the zeros to find the axis of symmetry. So they added the two zeros divided by 2. So you get 4 divided by 2 is 2. So that's our axis of symmetry. X equals 2. So that tells us where we would draw that line. So how to find the vertex using that? We take that 2 and we plug it into the formula that they gave us. -2 plus 1 and 2 minus 5. So I get -3 times -3, and that's a negative times a negative, and that equals 9. So now we know that the vertex is 2, 9. Don't forget to put it together. Here's my x, here's my y, here's my vertex. So now that I've got a vertex and an axis of symmetry, I can go from there and I'm going to draw the parabola. Okay, so they gave me 3 points. 1, 2, 3. But I've always said that you should have 5 points. So what I'm going to do really quickly is I'm going to take my equation, negative, I'm going to multiply the two factors out. I'm going to FOIL, so I get x squared minus 5x plus x minus 5, negative x squared minus 4x minus 5, and then I'm going to distribute the negative. I get x squared, negative x squared, plus 4x plus 5. And now really quickly I've got a y-intercept, which I put right there, and then I do a mirror point, 1, 2, 1, 2. That gives me my other point, and now I have 5 points, and I can draw a nice smooth graph. And the domain of this one is all real numbers, and the range I determined from my vertex. Y is, and it's a happy face, so it has it's a sad face, so it has a maximum. So it's y is greater than or less than or equal to 9. Whoa. Okay, so it's y is less than or equal to 9 because the y values are all below 9. Okay, so this one is from your journal as well. This is problems 2, 3, and 4, and they want you to identify the x-intercepts, then the axis of symmetry, then the domain and range. So I'm going to quickly go number 2, and I'm going to say my x-intercepts, and they also call these roots. Another name for these is roots or zeros, just depends on what book you get, or solutions. So those are all other names for the x-intercepts. Okay, so my x-intercepts here are 2 and 3, and then I divide by 2. I get 2.5, 5 over 2. 2.5 is my axis of symmetry. Okay, so there's my axis of symmetry. Now I take that point and I plug it into that equation. So y equals, because I need the y for my vertex, y times 2.5 minus 2 times 2.5 minus 3. And so I'm going to get negative 3 times positive 1/2 times negative 1/2, and that equals 0.75. Don't forget to multiply by the 3. So that's 3/4. So that tells me that since this is a sad face graph, okay, I know that it's a maximum. So my maximum is 3/4. Okay, the same thing there. And my vertex is 2.5, 0.75. So since my maximum is 3/4, and it's a sad face, I know that y is less than or equal to 0.75. So that's that, and my range, this is my range, sorry, and my domain is all real numbers. Okay, let's do number 3, and you can pause this and try them before me, without me if you want. The x-intercept, there's usually 2, are -5 and -1. So I'm going to add those together and divide. I get -6 over 2 equals -3. So that is my axis of symmetry. Remember, we always want to write it as a line. Okay. And now we're going to plug that into our equation. -3 plus 5 and -3 plus 1. This is my y. So I get y equals 2 times -2. Okay, so y equals -4. So my vertex is -3, -4. Okay, and then since this is a happy face graph, I have a minimum, so my minimum equals -4. Oops, equals -4. And then my domain again is all real numbers because there's no limits on it. But my range, think of it, it's everything above here. So it's y is greater than or equal to -4. Make sure you put a y with your range, okay? X can just be all real numbers, okay? All right, here's number 4. We have the x-intercepts. Remember your other names, are 3 and 1. Okay, so I'm going to add 3 and 1 and divide by 2. I get 4 over 2 equals 2. So x equals 2 is my axis of symmetry. Okay, and then I'm going to plug that in. Y equals, don't forget your whole equation, -4, 2 minus 3 times 2 minus 1. So I get -4 times -1 times +1 equals 4. So now I've got my vertex is 2, 4. This is a sad graph, so I have a maximum. My domain is all real numbers because these go on forever. And my range is my maximum equals 4 because it's the y of the vertex. And my range is y is less than or equal to 4. So there are all of your answers for that one. Okay, everybody good with that? Okay, the last thing we're going to do, there's the answers just in case you want to check. Okay, so the last thing we're going to do is graph a line, which is pretty much what you're going to be expected to do on this in this unit. So first thing I'm going to do is I'm going to find my solutions, or my x-intercepts, and they are -3 and 1. So I'm going to find my axis of symmetry by going -3 plus 1, divide by 2. I'm finding the average, and I could mark them 1, 2, 3, and you can sometimes do them from the graph pretty easily, so you can probably see what that answer is. -2 over 2 equals -1. So now I'm going to draw my axis of symmetry. Okay, so there's my axis of symmetry. We usually draw it as a dotted line. You can still use a ruler. So now that I've got that, I'm going to find my vertex. So I'm going to plug my x in, -2 times -1 plus 3 times -1 minus 1. So that's -2 times 2 times -2, and that equals 8. So we're going to make each of these by 2, so 2, 4, 6, 8. There's my vertex. Okay, my axis of symmetry is x equals -1. My vertex is -1, 4. Okay, now remember how I showed you if you want to get a nice neat graph, you're going to go ahead and find your y-intercept. So I'm going to go ahead and multiply this out, -2, FOIL the two binomials, x squared minus x plus 3x minus 3 is x squared plus 2x minus 3, and now I'm going to multiply everything by that -2, -2x squared minus 4x plus 6. And there's my y-intercept. So now I'm going to graph that. I'm going to do it in a different color. So there's my y-intercept. And remember, it has a mirror point. So this is a distance of 1. So I have a mirror point right there. And so now I would nicely graph that through those nice points, and it's going to look like that. Okay? So that is the end of this slide. You can repeat it if you need to, but hopefully that will give you enough information to finish your homework.